This is Sujit Mahatan, and I'm a student at Pulchowk Engineering Campus, for Masters in Knowledge Engineering, and today I'm going to present on Semantic Web. So this is the slide by Professor Aman Sak. So what is the Semantic Web? So it was designed by Tim Berners-Lee to share information, right? So Semantic Web takes the idea of sharing information further. So when we are sharing information, there are actually three parts of sharing information. One is first is somebody needs to have that information, and somebody decides that he or she need to publish this, right? And whenever we are thinking of publishing, we need to choose a schematic that is understood by both reader and publisher. So, and after that, if there is a shared understanding of semantic that is used to represent the knowledge or information, right? We need to be able to disseminate the information, and this is how information sharing process happens. So, for example, uh, a news. Okay, so if something happened, right? Agency like Kantipur or CNN will decides whether they want to publish it or not, right? And they do that. They choose a schematic, right? It could be a newspaper, right? Or it could be their website. So uh, website uses HTML. That semantic is being understood the the browser. Meanwhile, it is also being understood by as a news source by uh, user as well, and through web, right, through internet, the information is disseminated to the required person, right? So when there is so the health of our society depends on the how much can the information and knowledge can be shared. So this as there is more shared information, there will be better utilization of resources, and we can generate increased value from this. So so when shared information is put together, we get some valuable knowledge. So for example, this is the web page of the IOE. This may be an old website. So if you go to this page, right, they have decided to publish various information about IOE in this website, and we can get that information when we visit this website. So, uh, so if you think about our current system of system that we use in the internet, right? This has been mainly designed for human to view, right? So only human can understand web pages. It has uh, division, different tags, right, which describe the visual aspect rather than the semantic gaps of the document. So this makes them hard to be understood by the computer itself, right? Information is hard to be information is understood by the computer itself. So it's hard to do the data processing and automation. Not only that, right? Since there is uh, since it's only made for human to consume the information by viewing, if the sharing data across different application is also little complicated, right? Unless there is an API, and through this some shared another schematic or another protocol for the interchange of data, right? This can't really be done, right? Uh, so it is also hard to integrate the data from different application uh, that you may want to get a meaningful result, right? So semantic web was introduced by Tim Berners-Lee, who is the inventor of the World Wide Web as well. So it's an uh, extension of current web in which information is given in well-defined meaning, better enabling computers and people to work in cooperation, right? So this is definition of semantic web by Scientific American given in 2001, and it has already been a decade, 2 decade actually. So so it allows data to be shared and reused across application, enterprise, and communities boundaries, right? So uh, this, this uh, semantic web approach uh, tries to utilize our Vision's web as a distributed database of knowledge, and which can be used for the greater purpose, right? Greater human purpose. So it has been like promoted by the core effort by Worldwide Red Consortium in participation of large number of researchers and industrial partners. So, so, uh, so what does the semantic web consist of, right? So it consists of following parts, right? It is a web of structured data. So if we want to see example of how structured data is, we can see in the graph just adjacent to this slide, right? So a software can has if it is a website of software, it can have manual, right? Can have other requirements, libraries, so it can point out that in a meaningful way, right? So the document can also refer to another document, right? And they can have an image, and all of those document will have some topic, right? And those document will also have author, and the uh, author will also there could be some additional information about the author itself, right? One of them could be where he lives, right? So this is how the semantic web can be written, right? And maybe what we want is we want all the documents that has been created by a specific person, software related documents that has been created by specific person. So how do we like find them out, right? So that's a problem, right? So maybe we may want to like aggregate the number of documents created by different person based based upon their ethnicity. So something like that, maybe, which you may not think people would really want, but some people may need such kind of critical information. Right? So uh, this is our web. This is defined by the structure, web structure data, right? But web structure data can be defined as a node or documents that are linked with each other. So we can see that this uh, this resembles the current wave, right? Because there is link. But what is different from the current wave is the semantic meaning. So when software is pointing to the document, it it is referring that this is a manual, right? When software is pointing to the library, it is referring to them that this library is the requirement for running the software, right? So this kind of information, if we can provide in a machine understandable way, then we can say that this is a path to our semantic web, right? So that is two parts. So, and the third part is data modeling and knowledge representation, right? So we can model this data and knowledge as a graph or as a graph database, right? So not only that, if we can understand and the standard for data exchange is open, then we can understand each other's, right? So interoperable data standard is one of the component of semantic web, right? So if we what is if we think about web, what is web? It's just a document that can link with each other, right? So uh, but it can not only link with um, web pages, it can also link to images, it can also link to mp3 player, movies, it can also link to some pdf file, etc., or file, etc., right? So this is how web current web is organized. So as we already know that the semantic web thinks as web as a distributed database, right? So uh, so web of so you can think of web as a giant global uh, database with meaningful data link, right? So this is one of the example, right? So so when we go to WTO.org homepage, right, we could say that you could see some meeting maybe, and some meeting that is chaired by somebody, and that's being attended by somebody, and we can also get the contact details, right? And we can also know where the actual event is going to occur, right? And maybe we can specify additional information of work location, like latitude, longitude, and postal code. And the organization may have something like a privacy policy, right? So if multiple people use the same um, terms and terminology to describe this data, right, we could potentially use aggregate this kind of data with another data from different users to make some meaningful get some meaningful information out of it, right? So Not only that, one of the major concept of semantic web and linked data uh, is uniform resource identifier. So, in this example, we are looking the the Yangtze River of China, right? So it is being described over here to be a river of specific length being located in a country, China. So Yangtze River or Yangtze node could have a specific URI, right? While China can have another URI and it can link with each other, right? And Beijing could have another URI. So it's just trying to point, uh, it's just pointing to the other node which have more information. So resource description format is one of the XML format. Let's say XML format that can be used to define this kind of a graph data model, right? So it defines thing in terms of of tuple of three elements called triples. It has it can be graphically denoted uh, as a uh, as a graph that in which a subject node points to the object with uh, predicate or information between them in the edge as well. So as you can see, so if a software is pointing document as a manual, so our predicate is manual, while software is subject and document is object. So this is one kind of method of representing graph data. So linked data. So linked data, it's uh, one of the, like, let's say, one of the way of going to our semantic web. So uh, so in linked data, what we do is publish interlinking structured data on the semantic web. So basic principles of linked data is use URI as to identify things or identify nodes. Use HTTP URI so that we can locate and look up and dereference these things, right? So it's very similar to web, in which you URI is used to used to denote where person needs to look up when for getting extra information, or right. So it provides a useful information when its URI is different. So this is the same thing. So the include links to related URIs to improve information discovery on the web. So this so in this way, like, uh, information discovery on the web can be improved. So this is a linked data initiative has been started after Tim Berners-Lee's vision, right? And till 2010, all this data has been published in under linked web, and we can see that various data of various interest has been published under linked open data. So, what does the linked data uh, makes us do is that we can use this linked data to uh, bring create a beautiful application over the raw data that's being shared, right? So semantic web for semantic web to work, right, there should be data that's being shared, or the knowledge that's being shared, it needs to be in machine understandable semantics, right? So for that, the terms that are being used, or concept that is the relationship between different concept that is being shown, needs to be specified in some common standard, right? So ontology, some common ontology must be defined or used, right? So ontology is the process of modeling concepts and relationships that exist in a specific area or domain of interest. So we could search for some kind of ontology that uh, people are using, and use that to describe the knowledge. So knowledge, if you like, represent the knowledge in specific format, reasoning and inference could become possible. And not only that, if machine can understand them, then it could help create artificial intelligence as well. uh, we can also create an agent that can understand this semantic web data. uh, for example, we could example of this could be like Siri and Google's voice assistant device, right? That can look into the web for you to provide you specific information, such as when what is the weather today, uh, when some person was born, when is the flight from this place to this place scheduled, right? Etc. So not only that, if if the knowledge is represented as a semantic web, uh, we can uh, we can do the start the automated information processing, right? So this is the importance of knowledge representation in understood semantic, right? So in order to do that, right, so this is how it can be. This is the layer of this technology that we can use to do this, right? So uh, all the data are actually stored in Unicode, and URI is to used to refer to the node of each data, and all the data is like published in XML, using namespace or XML schema. uh, so uh, that is used to define resource description file, RDF file, uh, and there is RDF file is dictated by the RDF schema. So if we use some shared ontology vocabulary, we can use uh, some logic inference of logic to prove prove that there is not any discrepancy, and we can also trust the result if we like, yeah, trust knowledge is being shared by someone by using digital signature, right? So this is how semantic web layers. So for interoperable semantic standards, we need to have use some common ontology, right? So we need to have some consensus uh, on common formats that we are using, and this enables the interoperability and data integration between different organization or institute. So in this we can say that there are various social sites, and the information of one could be uh, by used with other by connecting them. So now where this semantic web can be used, right? So semantic web can be used to represent the complex knowledge management and representation, and we can use some semantic annotation. um, we can also use this to improve information retrieval. uh, so inference and reasoning about data on the web can be done using this semantic web. So we can do the data integrate can integrate data that's on the web, and we can use the multiple data from multiple sources to create some meaningful product as well. So we can link open data of different institution to generate valuable meaning. So thank you. This is semantic web. So the main concept is that the data should published on the web should be not only human readable but machine readable as well, so that the whole web can be think of as database, a distributed database. Thank you.